chemistry teacher. As you know, I have been uploading a series of videos for you. Maintaining that continuity, today I have made a video which is on the topic questions based on oxidation state or oxidation number. In my previous video, I have discussed with you in detail about the rules regarding the calculation of oxidation state or oxidation number. Today, I would like to discuss the application of the rules which we have learned with the help of equations. Usually, question related to the calculation of oxidation number and oxidation state is asked as, in the question, the element whose oxidation state is asked to calculate, is given to calculate, is marked to indicate for the calculation. I am providing you a common language of the questions which are used in the examination. Question is asked as, calculate the oxidation state or oxidation number of the element underlined. This is an indication. Calculate the oxidation state or oxidation number of the element underlined in the following compounds or ions. Question is asked like this. Suppose you have, in our question we have given KMNO4, a compound, and Mn is underlined. K2Cr2O7, where Cr is underlined. NaNO3, sodium nitrate, where N is underlined. H2SO4, sulfuric acid, where S is underlined. HClO3, chloric acid, where Cl is underlined. HClO4 perchloric acid, where Cl is underlined. NH3, N is underlined. Mg3N2, N is underlined. CaCO3, C is underlined. Now some ions, MnO4 minus, Mn is underlined. S2O3, 2 minus, S is underlined. C2O4, 2 minus. NO3 minus, N is underlined, etc. In the questions, few compounds and ions are given as. Now, one by one, I am going to calculate the oxidation state of all the compounds and ions which I have written here on the board, so that you can understand the applications, how to use the rules which you have learned, and on the basis of that you will become confident to solve all such kinds of questions given in your book. The first of all, we shall solve KMnO4. In this compound, we have to calculate the oxidation state of manganese. Dear student, please care. The rules which we have learned, among all these rules, one rule is the total algebraic sum of oxidation states of all elements present in a compound is 0, which I have used here. The total sum of all these oxidation state of all these elements is equal to 0. And in one of the rule you have read, potassium is an alkali metal whose oxidation state is always +1. We use +1 for potassium. +1 for potassium. And consider, let the oxidation state of manganese is X. And in another rule we have learned, the oxidation state of oxygen in compounds and ions is commonly -2. Here we shall use -2, and we have defined oxidation state, in which we have learned the oxidation state is always calculated per atom of the element. Here the oxidation state of oxygen is -2 for one atom of the oxygen, and there are 4 atoms in this molecule. So we shall multiply minus 2 by 4 and then we shall calculate the value of x, which is equal to minus plus 8 minus 1, that is plus 7. We can indicate all these oxidation state here. Potassium plus 1, that we know from the rules, oxygen minus 2, and manganese we have calculated plus 7. Right? Now, the second compound is given K2, Cr2, Cr2O7. Again, it is a compound. How shall we understand compound or ion? If no charge is given on the group of atoms, it is compound, it is molecule. If it is charged, it is an ion. So, it is a compound. Again, we have to use two oxidation state, like the first compound for potassium plus 1 and for oxygen minus 2. The use plus 1 into 2 and let oxidation state of one atom of chromium is X and two atoms of chromium are there in this compound. Therefore, it is 2x minus 2 into 7 is equal to 0. So plus 2 plus 2x minus 14 is equal to 0. Therefore, 2x is equal to 12, x is equal to plus 6. Again, you can indicate all the oxidation state like this. Right. The third question is NaNO3. It is also a compound. Now, sodium is again a alkali metal. It belongs to the group of potassium. So we shall use plus 1 for sodium and we have to calculate the oxidation state of nitrogen here. Let the oxidation state of nitrogen is X and the oxidation state of oxygen we have learned in the rule is minus 2 multiplied with 3 and the total sum is 0. Calculate the value of X, it is 5. Indicate all the oxidation state per atom of the element on the element in the given compound like this. The fourth compound which is given in the question is H2SO4. Sulfuric acid is a very popular compound, you know, in which we have to calculate the oxidation state of sulfur. Under the rules regarding the calculation of oxidation state, we have learned the oxidation state of hydrogen in a compound or ion is plus 1. The oxidation state of oxygen in a compound or ion is minus 2. The use plus 1 into 2 for hydrogen. Let the oxidation state of sulfur is X. Minus 2 for oxygen multiplied with 4 and then you can calculate the value of X, which is the oxidation state of sulfur. X is equal to plus 6. Right? The next compound is given is chloric acid, HClO3 is equal to 0. It is also a compound. Again, you use hydrogen plus 1. Let The oxidation state of chlorine is X. Oxygen is minus 2 into 3 is equal to 0. X is equal to plus 6 minus 1 is equal to plus 5. Now the sixth compound is HClO4 perchloric acid. It is called perchloric acid. And we have to calculate the oxidation state of chlorine here. So like the above compound, we can calculate the oxidation state of chlorine in this compound. Plus 1 plus X minus 8 is equal to 0. X is equal to plus 8 minus 1, that is plus 7. Next compound is NH3. Is very simple. It is a compound of only two elements. Ammonia, we have to calculate nitrogen, and you know the oxidation state of hydrogen is plus 1, therefore it will be minus 3. The eighth question is Mg3N2. Mg3N2 is equal to 0. Magnesium is an alkaline earth metal. In the rule we have learnt, the oxidation state of alkaline earth metal in the compound and ion is plus 2. To use plus 2 for magnesium, multiplied with 3 and 2x lead for nitrogen, plus 6 plus 2x is equal to 0. X is equal to minus 3. The next compound is CaCO3, calcium carbonate, in which we have to calculate the oxidation state of carbon. Again, calcium is alkaline earth metal. Let X for carbon, minus 2 for oxygen, and calculate the value of X. It is plus 4. Now some ions are given. So we have learnt in the rule the total sum, the algebraic sum of oxidation states of all elements present in an ion is equal to the charge present on the ion. So here it is a permanganate ion, MnO4 minus. So we shall write is equal to minus 1 because this ion has minus 1 charge. The total sum of the oxidation state of all these elements will be equal to minus 1. Here we have to calculate the oxidation state of manganese. Let my X minus 2 for oxygen multiplied with 4. X is equal to plus 7. The next ion is thiosulfate ion. S2O3 2 minus is called thiosulfate ion. In thiosulfate ion, we have to calculate the oxidation state of sulfur, and the charge present on thiosulfate ion is minus 2. The late for sulfur it is 2x minus 2 for oxygen into 3 is equal to minus 2. So 2x minus 6 is equal to minus 2. 2x is equal to 4. X is equal to plus 2. The next ion is given C2O4 2 minus. It is called oxalate ion. And it has charge minus 2. we have to calculate the oxidation state of carbon. The oxidation state of carbon is X. There are two atoms of carbon, therefore it is 2X, and minus 2 into 4 for oxygen is equal to minus 2. The 2x minus 8 is equal to minus 2. 2x is equal to plus 6. X is equal to plus 3. Next one is NO3 minus is equal to minus 1. X minus 2 into 3 is equal to minus 1. X is equal to plus 5. This is the way to apply all the arbitrary rules which we have learned in the calculation of oxidation state or oxidation number of elements. And it is very important, but the more important point which we have to know on the basis of these calculations is the concept of oxidation and reduction, the concept of oxidizing agent and reducing agent, the identification of the substance undergo oxidation or reduction. These all points can be identified, can be indicated on the basis of oxidation state of the element. Dear friends, I would like to give a question which contains like these some compounds and ions for your practice, because in the book of your class level such kind of practices are not given. Therefore, I would like to give you some compounds indicating the element whose oxidation state you please calculate at your home. You try your best, and I shall share the answer of all these compounds and ions which I am providing you in this video. I shall share with you the answer of all these questions so that you will be able to check your answer in the next video. Now the same question as your homework. Calculate the oxidation state of the element underlined. Underlined in the following. In the following compounds or ions. HCl. N3H. KAgCN whole 2. H2SO5. H2S2O8. NiCO whole 4. Nickel carbonyl. This compound is called nickel carbonyl. S4O6 2 minus. PO4 3 minus. PO3 3 minus. NH4 plus N. NO2 minus N. Now NH4NO3. Here, the two nitrogen atom is there in this compound, NH4NO3 ammonium nitrate. Here you have to calculate the oxidation state of both of the nitrogen atom because they possess different oxidation state. CrO5 chromium peroxide. H2CO3 carbonic acid, etc. Dear friends, don't worry. Revise the rules provided by me. Revise all the rules provided by me in the previous videos. Revise the practices which I have shared with you in this video, and on the basis of that you take this question as your homework. I hope all of you will try your best to calculate the oxidation state of the elements underlined in these compounds and ions. And the answer of this question I shall discuss with you in the next video, so that you will be able to check the answer solved by you. Okay? Thank you. Dear friends, as I have told you previously, I wish to discuss redox reaction in detail, which is more than as per the curriculum of your class 10th. This discussion on the redox reaction will make your concept clear about this very important kind of chemical reaction, and we have to discuss in this chapter the use of this redox reaction in our everyday life, which you will also be able to understand. For that, I am discussing this reaction in detail. Please cooperate and read carefully. Okay?